Okay, this will be the finishing up of section 9.2 in Algebra 2. Still working with logarithms here. We've kind of seen how to convert from log form to exponential form, and we're eventually going to use these to solve some equations. So just a little bit more. This is kind of a brief finishing up of 9.2. A quick little warm-up recap. If we want to evaluate a logarithm, like the log base 3 of 243, sometimes it might help to just think, let's say it equals something. I don't know what it equals, so let's call it x. Um, if we remember how to change forms on that, remember you can take your base to the exponent of what the log equals the number you're taking the log of. Remember that's just the changing the formulas here. So we end up with something like 3 to the x power equals 243, and we saw how to solve those last section, um, where we would try to write them both as the same base. So 3 to the x equals, if we recognize 243 is really 3 to the 5th power, then we can come up with, the bases are the same, we can come up with x equals 5, and there's our solution. Okay. Now some of you guys might be thinking, I know there's a log button on the calculator, what does that do? Um, so if you go ahead and type in log 100, okay, if you do that, so if you have a calculator handy, go ahead and do it. If not, you can kind of take my word for it. It's going to give you 2. Okay, the log of 100 equals 2. So the question is, when we write logarithms, like up in example 1, we had a base that was given to us. Okay, and when we throw it into a calculator, it doesn't really ask for a base. So the issue is, what base is it using? Um, so if you kind of think about what a logarithm is, and it's a big concept, don't get through this whole chapter and then at the end, still not know what a log is. It's one of those things where you see it and you might know how to use it, but if I just came out and asked you, what is a logarithm, what I want you to think about is a logarithm is basically asking what power, okay, what power do you raise the base to? Okay, so in our example here, our calculator told us that the log of 100 equals 2. So the question is, what is the calculator using for the base? What are they assuming the base is down there? And it's kind of like what number to the second power equals 100? Okay, so this one you can kind of solve, just kind of thinking about it. What number squared equals 100? I think we could all agree that the number, the question mark there, the base would be 10. Okay, so that's kind of key. When you use your calculator and you just press log, it's assuming the base is 10. Okay, so a little bit more on that later. Okay, let's do a couple examples of solving equations. That's kind of where we're going here with some of this log stuff for now. So let's say we have an equation like that. Um, and we're trying to solve, our variable in this case is in here, but we're taking the log of a plus 6. So what you want to do with these is treat it like any other equation. Try and get the variable by itself. So what we need to do in this case is we want to actually get the log by itself first. So then we can do something with it. But my first step is let's subtract the 4 from both sides, and let's just get the logarithm, because that's where the variable is. It's part of the logarithm. Okay, so 3 minus 4. So we would get the log base 2 of a plus 6 equals negative 1. Okay, now it's kind of, like, what do we do now? We can't really just divide by log base 2 and get that log base 2 out of here. But we need to do something. Okay, so what we need to do is change forms here. If we change to exponent form, okay, I guess I got on a highlighter somehow. Let's change that to pen. So if we go to exponential form, okay, back in the previous examples, if we take the base to that power, it must equal the thing we're taking the log of, basically. Okay, so that's just that changing form. Base to a power equals the thing you're taking the log of. And now the logarithm's gone. Okay, it's not in our problem anymore. We got rid of it. So we have kind of a more normal equation. And we just got to remember what to do with 2 to the negative first. Remember, a negative exponent means reciprocal. Okay, so it's 1 over 2 to the first. It's 1/2 equals a plus 6. And then we could just simply subtract 6 from both sides and solve that for a. So 1/2 minus 6 gives us our answer. If we just want to go decimal, negative 5.5 equals a. Okay, so if you're ever stuck in an equation with logs, usually, changing forms is going to be the way to go. Okay, sometimes you'll have to change to log form to solve equations, but usually if there's exponents or logs, try and change forms and you might get a fairly straightforward equation like we got here. Okay, one last little property in this section, it's similar to something we saw previously. We saw previously, I believe, it was written more like if you have a base to a power equals the same base to another power. So if the bases were the same, then we said x has to equal y. And we actually used that in number 1 in the warm-up to solve that a little bit. This is kind of very similar. If you notice, on both sides of the equation, they both have a logarithm. And they're both with the same base, log base b, log base b. If that happens, and there's an equation setting them equal to each other, then we know that the x has to equal the y. Okay, so if they're both log to the same base, of the same base, then the things you're taking the log of must be equal to each other. Okay, so let's look at a quick, application or use of that. An equation like this. So we want to solve log base 4 of x squared equals log base 4 of 4x minus 3. Okay, so this is that exact case. If we notice both of both sides are log base 4. Okay, so it's almost like those just kind of cancel out. I wouldn't just go crossing them out or anything, but what it does leave us is that x squared must equal 4x minus 3. Okay, and it's again because both were the same base. If they're not the same base, we can't do that. But in this case, they were. So this is a good use of that property. So this looks like a quadratic equation. Okay, so at least it's not a log equation anymore. We got rid of the logs, but it is quadratic. We got to get it set equal to 0. Let's basically subtract the 4x, and we'll add the 3 over. Get it set up equal to 0. Okay, so 2 steps there. I subtracted 4x, and then I added the 3. So make sure you follow those steps. And I knew to do that again because it was a quadratic. That second power in there. So they're all based on setting them equal to 0. And then you can try factoring, you can try quadratic formula. This one I believe is factorable. I know I need an x and an x to get the x squared piece. Can I get some factors of 3 that add up to negative 4? Yeah, I think I can use minus 3 and minus 1. Okay, so some old factoring. It doesn't show up all the time in these problems, but once in a while you have to recall some old things. And then of course we can set each piece equal to 0. And get our solutions. X equals positive 3. Okay, or set the other factor equal to 0, x equals 1. Okay, so 2 answers there. And those should both work. Okay. Right, and I believe that actually wraps up the section. So again, we had part 1 separately, part 2 here, and we will continue more with the logarithms in the next few sections.